I'm going to change the format this time. I'm going to keep it a lot quicker. I'm not actually going to go through the software. I'm just going to show you where I've got to with the software. But before we do that, let's have a look at what I said I wanted to look at next, which is sensors. So we've got a classic sonar sensor there. If we go over to the rostering camera, you can see we've got a lovely little thing called a time of flight sensor. What that does is that uses a little laser beam and actually measures the time that the light takes to fly between the target and returning back to the actual sensor. Very accurate, extremely interesting, and probably about the same price as the sonar, but theoretically a lot more high tech, but we'll see. And then something I've never used before, which I want to have a look at, which is infrared. Oh, and I've thrown that in. I still cannot believe it is possible to put a complete satellite GPS system on a board that small, but there it is, and that's not an up-to-date one. That's probably about 5 years old. I got that for a project that I never took any further, which we might go back to, since lockdown's now causing us to all re-evaluate this time, which is based on a big lawnmower, on a robot lawnmower. So we've got all our bits there. Slide those over, and as I said, over in the UK we have a program over here called a children's program called Blue Peter, and what Blue Peter used to do was have a running joke that this is one I prepared earlier. So this is the robot where we are at the moment, and with my favourite little bit of blue tack, we've got a time of flight sensor on the front, and what I've done is I've created a little bit of software, or I've modified the existing routine. Now I'll go through the existing routine and show you how I've modified it and why I've modified it, and then I'd like to throw it open for everybody to see whether you can improve on the code, because I aren't very happy with it. I don't know whether it's just a factor of the Arduino or the fact that it's trying to do too much with the time of flight, but it does seem very slow to me. Again, it could just be that I'm not using the time of flight in the best way. So as I said, we've got the time of flight sensor right on the front there. So we've still got the sensors on the whiskers, and so basically I'll show you the programming. So what I've done is I've added to the front a few libraries. I've put the YH library in, I've put the component object library in, range sensor library, and the SparkFun VL53L1X library in. Now I've got to say I've thrown all those in because that's what the example said. I haven't had enough time yet to sit down and find out what it does need and what it doesn't need and what each of them do. I just wanted to do this quickly. Two-wheeled robots are something that I enjoy, but I'm not spending my life on them just at the moment. So I've included, so what I've done is I've added in the wire component, range sensor and SparkFun libraries at the beginning. I've got to say, I don't know which of these are actually contributing at the moment. I've just put them in on the basis of that's what the example said, and I use a different library when I'm using the time of flight sensors, purely because I just wanted a much simpler solution. But I thought if we put the whole thing in, then you've got the option to use whatever you want. I haven't connected the shutdown or the interrupt pin, and I do wonder whether they actually will add anything. But at this stage, as I say, I'm more interested in let's see what everybody else can do with it. I've added in two variables, my distance, my dist and my valid, which obviously my dist is the distance measured, and valid allows you to actually decide whether it's done a valid read. It will actually check its own reads and actually see whether it thinks it's done a good read. The rest of the items are still the same, but what I have done, which is worth noting, I've gone in and I've created some arrays now to replace those variables there. So what we've got is we've got the motor pins are now in an array. We've got an array that's set out for the motors, and then we've got a PWM array that's set out as 4 separate motor directions, I think is the way to look at them, because again we're looking at object orientation. Again, I've got my factors and the things that allow me to alter things, keeping everything parametric. I did for a while add the serial begin because I wanted to keep track, and I've added the wire begin into the setup, which this is where your the program you set all the sensors up, etc. This is what I mentioned before. Before we only had the delay in there. Now we're setting up the sensors, and again I've just gone for the examples out of the book, from the example, because I don't want to move away from that on a basis of keep it simple. The loop is very similar. I've added one extra item to the if statement, which is sliding off behind me. I'll just raise it up a bit. So what you've got is I've added to a trigger if the distance is less than 20 millimeters, and then added another if statement that if the distance is less than 20 millimeters, it treats it as if it's hit the middle back button. Just having adding into what the sensors are doing. So, but the rest of that remains similar, apart from, if you notice, instead of now calling the actual pins, I'm now calling what I call my engine. Now again, this is back down to going to object orientation, and I'm starting to speed up very quickly now. I'm hoping that you've sat down with, if you are following these tutorials, that you've sat down, put the software in, and copied the software to start with. And now I want to sit down and drop a big concept in, and perhaps I'll put the code on so you can get to it. But really, we're now sort of trying to get into the new concepts of using object-orientated tools, so that now all we ever do is call the engine. We set up and then we call, so that instead of, as before, it was a series of commands. What we're doing now is we're actually setting the motors on and off. Now at the moment that seems like a lot of extra work for where you're doing is setting up the conditions and just to achieve the same thing. But the idea is that because we can set all these conditions up and then we throw it over to the engine, and what the engine does, we'll come back to that first line, what the engine does is it goes through motor by motor and effectively sends the conditions that are set up to the motors, or effectively set it to the L298, and again with a routine within a routine, it calls up my move motors inside there, and my move motors effectively goes through and picks each of those memory locations up, and based on Boolean logic switches on the motors or switches off the motors. Might seem like a lot of faff just to do what effectively is a power on command, but what this allows you to do is we're now starting to let the robot run itself. Within that, as this my engine gets cleverer, what it will do is it will start making decisions. And so the whole idea is, what we're doing is we're saying we want you to do this, and then it will find a way to achieve that. It's very, very basic at the moment, but it is the beginnings of your AI. It is at the beginnings of understanding AI and how AI works. And what we're trying to do is we're sitting down and saying, look, we know you're really in charge of the robot, and this is what we want to do. And then sit down and learn the steps. Now, what it does at the beginning of my engine, it does a quick read TOF, which is your time of flight. And all that does is that runs a little routine down here which says It has a little while routine in which basically waits for there to be a valid read and then reads that and goes back. But just in the same breath, this could be any number of sensors. So what you're doing is you're setting up within your engine responses to stimuli from outside the engine, so that it can actually, the engine makes all the decisions. You're not constantly making decisions with outside the engine becomes the power. And what you're doing outside the engine is effectively trying to make suggestions or requests. What we'll do then is we'll actually, let's just double check that this is set up for, right, so that's actually on COM4, which is always worth doing because this is the first time I've programmed it on this machine. I've been doing my research on another machine in another room. We'll then program that through, and let's just actually see what it does in the arena. Of why nothing was running, it looks like the time of flight sensors died. So between my final test last night and my coming back to do this tutorial, I've either bumped it or it got finally died in the last test yesterday evening, and I've had to replace the time of flight sensor. So this is part of the learning curve. Things go wrong, things happen. So that time of flight sensor now is not the one I showed you at the beginning of this tutorial. But it's the same piece of blue tack, so we're all going forwards. So we'll go back to the software. Now then, what I'm going to do is I'm going to go in there and alter my pulse width modulation down to 80. I want to particularly slow this down because one of the things that was quite apparent yesterday evening, and possibly was the death of the sensor, was this thing was bumping in quite badly to the walls because the time of flight didn't have time, or the processor wasn't processing the measurements fast enough. And this is again why I'm interested in your input on the software to see whether you can improve this software. So what I've done is I've actually moved that back, that sensor back, which actually, look at it, it actually isn't as far back as I perhaps like it. So I'm actually going to employ the best part of blue tack to make a field modification. We will then go over and upload the software, and then let's see what happens in the arena, which should be interesting, because I don't go and test these before I show them. Yeah, you're seeing my learning alongside these tutorials. I don't like to preempt what's going on, so we've programmed the robot, which I'll disconnect that now. We'll turn the power on and we'll reset it and go over to the arena. Apologise for the microphone noise. I took the microphone off and so it's looking to me like it's getting stuck in logics, and this is where one of the things that's good about doing testing and trying ideas out, that there's no such thing as a failure. They're all just steps in learning. But that robot looks like it is definitely getting trapped. And if you look at it, I think what's happening is that the sensor's triggered there, which is getting it to go back and go backwards and then pull the left motor. And then as it comes back in, the time of flight sensor is tripping and going straight back. So that what we're doing is we're getting locked in to what looks like the same movement each time, and what we perhaps ought to do is pull away and potentially go right as opposed to going left. So I'll grab the robot. I apologise for the mic noise. got the robot and see if we can quickly do a change in the program. So, plugging back in. Apologise for the microphone noise again. I like I say, I want to do these tutorials on the fly if possible. So, going back to our software, what we've got down here, we've got if anything triggers, the first thing it does is go backwards and drops with a delay and calls the engine. So we know it's going backwards to start with. So if it triggers, if it's left, it adds my left back. So what should we actually try a right back there? And on that logic, alright, yes, so it's also doing left back if so let's change the distance trip to backwards, and then middle, just was a delay in, so therefore that's a bit backwards, and let's say let's alter this on that logic to left. Let's do a quick syntax check. May as well have programmed it. I was thinking that the syntax check would be quicker, but it's actually doing a sort of compile. Keep forgetting. Yeah, too many IDs, too many different languages. So we'll program it, and let's see whether that improves things. So we should see the software come in. There we go, programming in. Go to the arena, unplug the robot, reset it, and drop it in the arena. So now let's see what happens. So much as before, so even though we've changed the way that it's going, it's now getting stuck in corners. I've got to say, we're getting away with it, but not out of good management. We've got a situation where the robot is getting trapped by its own logics. It looks like the time of flight's working, but I can't be sure without actually going and have a right good look at that. It's difficult to tell because the switch is triggering, and it's difficult to know whether it's the switch that is causing it to move. But if you notice, we're getting stuck in corners. And so this is where you can end up spending a lot of time trying to work out logics. And you can understand how when you see some of the AI software, do we know why it's changing? When we actually see all these changes in the AI, do we understand how it's working? If we can't understand how something as simple as this is going faulty, then trusting to AI to be doing the job is a big ask. Because one day, that AI may have our lives in its hands. So we need to know we understand what's going on. So, I'm going to have a play about with this and see what I can come up with. I'll be interested if anybody else wants to pick up or improve on what I've done. I mean, I literally have thrown this together in amongst other work I'm doing, just for the fun of it. Really, more than anything else, to inspire, if I can, because to me there are not enough people out there playing with robots. You know, at the end of the day, we don't want a small few people controlling our own future. You know, one day I might need a robot to help me. So I shall leave it at that, and thank you all again for watching this far, and let's have some fun. I'll put it back in the arena at the end. Nothing else. It's a bit fun watching it try to get around a corner. It also gives me a chance to use a piece of music towards the end. I'll send it that way this time. Let's see what it does that way. Do we think I've got it to turn for longer? It would certainly turn it away from the wall. Would it solve the problem? This is down to when you start getting into stuff like Fibonacci series, where you want to sit down and say, I'm going to actually make its decisions and how it treats and how it its movements based on Fibonacci series. It's amazing when you start doing that, how stupid things and the things suddenly start working well. So, thank you again, and switch in the arena.